channel. In this video, we are going to discuss about supermesh and supernode. In my previous video, I have explained how to solve problems using mesh analysis and nodal analysis. If you have not watched it yet, just check it out. And now we are going to learn about this supermesh and supernode. Suppose consider this circuit. For example, if you want to apply mesh analysis, say considering this first mesh, what happens is, say I'm trying to write the voltage equation of this first one. So what happens, it is minus 10 plus 3 into I1 minus I3. Okay, then what about the voltage across this element? We don't know anything about this, right? So we cannot complete the mesh equation of this particular mesh, and the same thing happens while writing the equation of this mesh also. So we cannot solve this problem using the mesh analysis. Okay, fine, mesh analysis is not possible. Why don't we try it with nodal analysis? Yes, I'm trying to write the nodal equation of this nodal equation at this node. So what happens is, V1, say consider it as V1, V2 and V3. Then what happens, it is V1 minus V2 by 3 plus V1 minus 2 plus V3 by 1. And what about the current in this branch? We don't know anything about this, right? So we cannot complete it in the nodal equation. We cannot complete it either here also. So we cannot apply the mesh analysis or nodal analysis too. So then comes the use of this supermesh and supernode. Okay, so the concept of the supermesh and supernode is, whenever there is a current source connected like this in parallel, while solving the mesh analysis, then we'll have to go for the supermesh. Otherwise, if we have a voltage source connected in this way while solving the nodal analysis, then we have to go for the supernode. Okay, I'll tell you how to do it. It's very simple. Let us start with the supermesh. Okay, so what you need to do is, you need of course we know that this is one mesh and this is one mesh, but since there is a current source connected in the mesh, so what we have to do is, we just need to pass it on like this. That is, in the previous case our mesh is this, mesh 1 and mesh 2, but now in this case we have to write the equation for this complete mesh, just eliminating this, but still the currents through the resistors being the same as the previous case. I'll show you how. For example, the supermesh equation for this problem is like this. It is minus 10 plus 3 into I1 minus I3, same as in the previous case. And next you should not complete like this, you should go on to this mesh also, plus 2 into I2 minus I3, because I'm assuming the current in this mesh as I2 and the current in this mesh as I3, so the current is I2 minus I3. Okay, plus 4 I2 is equal to 0. So what happens, the current equation, so the voltage equation is 3 I1 plus 6 I2 minus 5 I3 is equal to 10. So this is the first equation, and the second equation comes here. It is 2 plus, when you do it in the same way, it is 6 I3 minus 2 I2 plus 3 I1 equals to 0. So this goes the second equation. And the basic thing which we can observe here is, the current through this branch is 2 amperes. That is, it is the resultant of the currents I1 and I2. Since this is in this direction and I have assumed that the current in this mesh is I2, that is I2 is flowing in this way and I1 is flowing in this way, this 2 amperes is the resultant of I2 and I1, and it is I2 minus I1 is equals to 2 amperes, because I have assumed I2 in this direction and the resultant current is also in this direction, so I have to consider it as I2 minus I1, not I1 minus I2. Okay, so we have three equations, and by solving these three equations we will get the currents. The values after solving, I got these values. I1 equals to minus 0.068 amps, I2 equals to 1.93 amps, I3 equals to 0.27 amperes. Okay, now let us try to solve the same problem using supernode. Okay, now what's our problem is that we were not able to write the equation, that is KCL, for this node, because we don't know the current through this branch, right? So what we have to do is just put this node aside and start writing the KCL equation for the remaining two nodes, that is V2 minus V1, or you can directly take V1 as 10 volts because there is no other element connected in this branch. So the V1 equals to 10, so you can take it as directly, that is V2 minus 10 by this 3, and the current is entering here. In this nodal analysis we assume that V2 is the higher voltage than the other voltages, and we take as current is leaving from that node. But since the current is clearly entering this node, we should take it as negative sign, minus 2 plus V2 minus V3 by 2 equals to 0. Okay, now after solving this, what you get is 5V2 minus 3V3 equals to 32. This is first equation, and now I'm applying this is the equation obtained by applying the nodal analysis at this node, that is V2, and now I'm applying the nodal analysis at point V3. That is, what I will get is V3 by 4 plus V3 minus V2 by 2 plus V3 plus 2 minus 10 by 1 equals to 0. Here just observe this. This becomes a difficulty to many students, I have observed, because they feel difficulty in writing this equation. It's very simple. See, here we are considering V3 as positive, right? Okay, this is positive. Since this is the ground, this is ground equation because more number of voltage sources are connected to this principal node, so I am considering as the reference node, and this V3 is taken as positive here. And now while you are going through this equation, see, the V3 positive is connected to the negative. It is like this, plus 2, and it is V3. Since these are connected in series aiding, it will be V3 plus 2. Okay, don't get confused with V3 minus 2 minus 10 or V3 plus 2 minus 10. Yes, this is the point where most of the students face difficulty in writing this equation. It becomes whether they should put minus or plus. It's like this. Just write the voltage sources in this way. If they are in the series aiding, just add them. If they are in opposite, then just subtract them. Okay. In this case, they are aiding. So this is the equation. And after solving this equation, what I got is 7V3 minus 2V2 equals to 32. This is the second equation, and you can observe that there are only two unknowns and we have two equations, and after solving this I got V2 equals to 11.034 and V3 equals to 7.724 volts. Okay, suppose if they have asked suppose you are asked to find the current in this 4 4 ohm resistance, what you have to do is the voltage across this resistance divided by this resistance value, that is the voltage across this resistance is V3 in this case, right? So the current through 4 ohm resistance is given by 7.724 by 4, and you will be getting the 1.93 amperes. And what about the super mesh? Yes, the current through the 4 ohm resistance is I2, that is 1.93 amperes. Yes, both are same, and hence it's a proof that I didn't mess up any equation and the currents are same. Yes, so this is how you need to solve the problems using supermesh and supernode. And I hope this video is helpful, and if you like this video, just like it and share it with your friends. And if you have any doubts, just comment down in the comment section. And for more kind of these videos, just subscribe to my channel, and thank you for watching.